Hello everyone. Thank you for joining us today as a part of the Oculus webinar series. We'll be just starting in a couple seconds. Curtis Garton, the Visual Analytics Product Manager at Oculus Info, will be talking about using location data, fusion, and exploitation.
Okay, well, hello everyone. I'm Curtis Garton again. I'm the Visual Analytics Product Manager here at Oculus. For those of you who aren't familiar with Oculus, we are a visual analytics company based in Toronto, Canada. Our focus is really on trying to provide the right way to look at data so that a user can make decisions with it. They can create action with it. A lot of the time, what we deal with a lot of our users is the struggle with how to get accurate movement data. It's something that we work on quite a bit, is trying to understand movement and patterns, and the struggle always is, well, hey Curtis, we'd love to do more of that, but we just don't have enough location data. And so what we decided to do was to put together this presentation to try to highlight some of the ways that you can identify location information that you most likely already have, and then how to exploit it, how to make use of that in the most efficient way possible. So today's example is going to be focused a bit on some law enforcement scenarios that we've been working on recently, but this is certainly applicable to a lot of other industries and a lot of other workflows. So definitely don't think that this is just purely a law enforcement workflow that we're showing you here. What we focus on really is any type of location information, and I'll go through and explain really what we mean by location information. So first up, let's start at the very end. Why would you want to do this in the first place? What are we trying to get to? What's the benefit here of exploiting location information? So one of the things that we do a lot here at Oculus is help users to be able to see movement patterns. And so what I've got up here on the screen is the movement pattern from a GPS device. And if I show you the timeline, you can see that it's going downward. So Monday starts at the very top. That's when we started the GPS logger. And it goes down Tuesday, Wednesday, Thursday, all the way to the end of the week there on Friday. Now, if I were to show you where this individual works who had the GPS logger in his car, you can see that these four dots there, those yellow kind of circles there, what they show you are where when the individual is at work. So these are our working hours. And then if I show you his home location and the home hours, you're going to see where he's at home. And so by being able to look at this movement data and understand those two locations, you can see, well, hey, this individual is fairly regular. They have a routine of going to work pretty much 9 to 5, Monday through Friday. And that's very easy for us to understand now. Now that we understand what we're looking at, that there's a work location, a home location, and he goes back and forth, we've just identified our first pattern. Now, why are we identifying a pattern? Well, patterns are really important. First off, to understand what's routine, and then to be able to spot the exceptions, the times when someone is not following a pattern. And so this is why we really want to be able to find location information, to be able to aggregate it and exploit it. We want to be able to see movement so that we can find patterns, we can find areas where where travel is, where there's been travel that we weren't expecting. So there are going to be three themes in this talk. First thing we're going to do is look at where we can get this location information. Different sources, different types of data that all contain valuable location information. We're going to show you how we can aggregate this data together to create an accurate movement path. And this is something that's really exciting. It's like putting together pieces of a puzzle. And the more location information that we put into there, the better the puzzle's going to look, the clearer it's going to become. And finally, a very important step, which is how to present this result. How do we present this to others so that they can understand it? It's great if we go do a bunch of work and we create this wonderful data set of movement, but if we can't present it and communicate it to others who aren't specialists in this area, well, then the information is not that valuable to the organization as a whole. So we need to be able to present this. So we're going to talk about some best practices there. So first things first, location information. What is location information? Well, there's a lot of different types of location information. It's a fairly broad and general term, but we wanted to throw down some examples. So examples of location information. Your street address at home is an example of location information. The city you live in is an example of location information. Geographical coordinates. So if you got that Garmin device where you use to go biking, and it records GPS coordinates, the lat long there, well, that's location information. Landmarks and venues, the White House, that's a location. The Staples Center in Los Angeles, that's another location that can be used as a piece of data. Site IDs, so for things like cell phone towers, all these towers have IDs, and that's related to location, as well as network addresses. So, going beyond just geography, a computer network system also has locations, which are essentially, which computer or which server did this information come from. Getting a little bit more granular there, location data. So kind of more on the raw side of what types of data do we have access to. Things like ping tracking data, call detail records, GPS loggers, GPS trackers. This could be anything from your mobile phone all the way up to a Garmin device. ALPR data is a really interesting one. This is automated license plate reader data, something that is in use in many cities across North America as well as Europe. Surveillance logs. So if you have a surveillance operation on a suspect and your team is collecting logs, different sightings, and so forth, those all have typically addresses and landmarks that are recorded there. So that's very valuable location information. Mobile phone forensic data is one that's just exploding today. Obviously, more and more people have mobile phones, and these phones tend to record a lot of location information, and we're going to show you some examples of that as well. Financial records is another one. And there's a whole slew of other types of location data. Things like loyalty cards is another example where location data is recorded. So there's a lot of different sources of location information. The real question here is always how accurate is it? How dense is it? So if you think of something like a GPS device that's recording your position every 5 seconds, that's going to give you a really high sample rate, what we call a high resolution location accuracy. If you're looking at something like credit card transactions as another example, where at different merchants that you've been purchasing things, the sampling rate's rather low, so that would be more of a low resolution type of data set. So what we want to do here is we want to transform some of this raw data. So taking a look at some of these different data types and trying to put them together in order to create a higher resolution movement path. So what we're going to do is we're going to take 3 different data types. This is going to be details from an ongoing investigation. We're going to bring in call detail records, as well as some hits from an ALPR system, automated license plate reader. And we're going to merge these together. Now, what's interesting about this is that each one on their own does not give us a very good movement or a very accurate movement path. It's really the combined or the merged result that's going to give us the best possible view of an individual's movement. I'll show you what that looks like. So let's say these are our license plate hits, and these are the 3 locations where we picked up a license plate. Then we had 3 mobile calls that were placed, and so those are 3 different locations. Really, the fusion or the aggregation of these 2 together is going to give us a much more accurate movement path than either one of them on their own. And so what we're going to highlight here is just how easy it is to bring together these different location data sets in order to provide you with the most accurate movement path possible. So let's start off with investigation location information. So this can be really any type of logs that have been made that show things like a witness statement at this time and this location. Incident reports is great for that. Employment logs, criminal records, past past activity there. Crime Stopper tips is another one that typically has an address, a venue of some kind, a landmark, as well as a time. And so we're going to take some of these that we've already got entered into Excel here. So really simple data format. I've got a time, a date and a time, I should say. So we've got these two columns representing date and time. I've got an address. So here is where the notes were recorded. So 4th and Mason, 16 Horizon Court. And then a description. Well, the suspect was seen driving east. He was then seen walking across the street. Down here, there's a fatal shooting at 16 Horizon Court. And then I've added just some tags for it. So the source of it. Well, this was a witness. That was a witness. This was the actual crime that occurred. Then there was some security cameras that picked him up. And then I have the lat long information that's been included there, so we can put that on a map. What I'm going to do with this is I'm going to send this information across to our viewer, and this way we're going to be able to see this on a map. I'm just going to import those points there, and what we're going to see here are those events from our case logs there. And if I want to, I can bring this back and we'll play back the time range. So we can see kind of an animated playback of what these points look like. You can see I've got a bunch of eyewitness accounts down there. I've got a security camera that picked him up there, and then I've got him heading back out. So looks like it's kind of a north-south movement of the suspect. The problem with this view is that it's very difficult for us to get that full context of the movement. We just kind of see some overlapping points. So I'm going to change views into what we call the calendar view. And again, this is one of these situations where time is stacked. And so we start off here at the very beginning and we go downwards. So at the very beginning here, we have that eyewitness statement. Suspect was seen driving east. Then there was a few more of those. There was a security camera at a Shell station that picked him up, and then we had this fatal shooting back downtown here in the Toronto area. So this really doesn't give us a very accurate depiction of our suspect's movement. This is more kind of key elements that we have as part of our investigation, but this movement path really is just a line that connects those two together. There's very little accuracy into what the individual was actually doing in terms of movement. So we want to bring in another data source to help us augment that. So I'm going to bring in a second data set, which is going to be our automated license plate reader data set. So we have our suspect's vehicle registration and license plate number, and so we ran that through the database of license plates that were captured on a number of cameras. And what's great about this data is that it's fairly regular in terms of having fixed cameras that are reading license plate information. And in most urban areas within North America as well as Europe, there's just more and more of these being put up. So this is kind of a growing data set, and in a lot of cities, the number one mode of transportation really is the automobile. So in this case, we're going to bring in this ALPR data. And I've got a sheet of that there. Again, very simple data set. We have the plate that we were looking for, the date and time, the latitude and longitude of where it was picked up, and in a lot of cases we'll have the address as well of where the camera was situated. So again, I'm going to send this across to my viewer so that I can add it, I can merge this into the data I've already got there. So this is where our whole point about aggregation or fusion comes in, because I want to be able to join this stuff together. I want to not get rid of those events that I've already imported with the witness sightings there, but I want to be able to merge the ALPR with that. So now I've got these two different data sets that have been put together, and you can see I've got my license plate hits that are there, and I want to merge them so that they're going to be part of the same movement trail. So I'm just going to bring them all together, and now if we look back at the map, what do we see? Well, we see a very similar path up here. He's going back towards basically a suburb north of Toronto. He gets hit by that security camera at Shell, and then you can see he drives back downtown the same route right down here, This is where the shooting occurs there. And then you can see he takes the freeway this way back up, and he gets hit by 2 license plate readers as he heads back north. So he took a different path on the way home, and that could be interesting to us as part of our investigation. That's what the license plate reader data shows us. So we're starting to build up a bit more of an accurate path of what happened there. But let's go ahead and let's bring in one final data set, which is going to be call detail records data set. So as the investigation progresses, we were able to get a hold of the suspect's call detail records from the provider, and what this is going to do is it's going to provide us with the rough location of the mobile device as he was making calls on his mobile. And so we're going to add this data set to what we've already got loaded with our crime incident data and our ALPR data, and we're going to merge them together to provide us with kind of our final movement path there. And again, I'm going to merge these into there, so we're not going to blow away the data that we had originally. And now I've got all those data points in there. We're going to merge them all into one path, and that way we're going to have one path for our suspect. And that is my final view. Now, what's interesting about this view is that it gives me a fairly accurate depiction of my suspect's movement. So we can play this back. We can see he moved around downtown. He went back up north, got hit by the Shell security camera, made a call. Then he came back downtown. You can see here, right here, he makes a call just before the shooting, and then he heads back up north. And then when he's up north, you can see that he's made a few calls within close proximity to his home. So he's most likely hiding out after this incident occurred. So what I've got here is I'm just going to open up a one that we've already processed. I just changed some of the colors and added a few icons in there to speed things up. But I wanted to talk to you really quickly about how we present location data. So once we've got all this data fused together, we've got our fairly accurate movement path, and we're happy with that. One of the things that we need to be able to do is to present this to whoever we're working with, whoever's requested the analysis that we're looking at, whatever the audience is. We need to be able to explain this and to make sure that they understand what they're looking at. So the first thing that we always try to do as a best practice is try to frame the geographical area that the data covers. So the first thing is just to really show them, hey, this is the extent of the area as well as the time range. So this data set started on Monday at 5 o'clock in the morning and it went to Friday at 5 o'clock at night. That way they get a full sense of the merged data set. So all of the data is together. And then what's often nice is to be able to step them through the aggregation. Just step them through, okay, we added this data layer, we added that data layer, here's some ALPR data, here is some credit card transactions, and that way they can also build up that visual picture in their mind of what this movement trail really is. And then one thing that we find is very effective is showing an animated playback. Typically, if you are presenting to a non-technical user, someone who's not used to really looking at mapping and so forth, then create them a video. It seems to be the easiest and most effective way is just to show the movement, just like almost like watching a video game. So here, what I've got loaded is just a few notes I've created in my report tab, and this is the first step, which I'm going to show you the geographical context. So this circle here around shows all the geography that we're using, all the areas that these events occurred. Then we're going to go right in and we're going to show when the shooting happened and at what time. So now I've got this called out. And then I can also show things like the canvas area. So this is where we canvassed for witness statements and so forth. So we can draw these areas and regions in order to help us explain how we got the different data points that we aggregated together. And so that's a very useful capability to do there. one additional piece that we thought was really interesting, geotagged photos. So smartphones, typically when you take a picture, they're gonna record a location of where that picture was taken, and this is a great source of location information. So I just wanted to show you a quick example of how you can take that same data. So this is just a directory of photos that was taken from, in this case, my wife's iPhone of all places. So we are going to be seeing a few baby pictures in there. And we want to be able to see them over time. So we're going to show all of the photos. I think it's over about a 2-month period. Yep, there we go. And I'm just going to take this and we're going to call this Shauna. And now I've created an entity of all of Shauna's photos over a period between October 4th and the end of the year. And if I show you just a bit of that, we can see my son there. Here we can see how the photos create her movement path based on the time and location that they were taken. So what we would do with these photos is we would add them to other data sets that we have on Shauna's movement, whether that be ALPR data, perhaps parking tickets, any other location information that we have to help us refine this movement path. So it's not just the pictures, but it would be augmented by fusing together different data sets. And that is the conclusion of our presentation for today. I'm going to turn it back over to Adil, and we can go through some Q&A if anyone has any questions.